My name is Maxwell Friedman, and this is the complete guide on the A3Sat assembly. On this table is every part that you'll need for the A3Sat, from the frame to the electronics to the tools. This video will be broken up into parts, covering the assembly, the electronics, the software, and the usage of the A3Sat. Feel free to skip along as you need. The first step in assembling the A3Sat frame is adding the nuts, as you see here. I recommend using glue to add the nuts, as it's a much longer-term solution. First, add a few drops of glue on the outer perimeter of the hole. Then, add the nut and use pliers or a hammer to force them into place. Then, let the nut dry and you can continue with the process. Do the same thing for all 16 nuts on the frame. This is what all the frames will look like once all the nuts have been added. Just wait for them to dry. Keep in mind, these are the 6-32 nuts that are being used. Now that the glue is dried, you can go through the process of assembling the frame. First, take this side piece and match it with a corner piece. Keep in mind that the tab on the corner should face outwards and not backwards, like so. You can insert the screws and start them, but then you'll likely want to use a screwdriver to tighten them all the way. This piece then matches up with this piece at the corner. What you'll notice is that this has a line of 2 connectors that match up and a line of 1 connectors that match up. The 2 should be at the top and the 1 should be at the bottom. This is how you can differentiate the top and bottom of this piece. Screw them in, matching the holes up the same way as before. The screws that we're using at this time are the 6-32 screws, which fit the 6-32 nuts. Then you take another corner piece, like this one, which has the tab going outwards and not backwards, opposite of this one, and screw them in the same way. Sometimes you might notice that it's hard to screw the nut in at points. That is likely due to glue getting inside the nut from the gluing process. However, you should be able to force it through and it will be smoother every time you use it. Then you connect this piece with the 2 connectors lining up once again, which means that the dual connectors will go all the way around the frame, including on this piece. What I then recommend is taking the front-facing piece and installing the 2 connectors to that so that it can slide onto the rest of the frame. Keeping in mind, the tabs should face outwards like this. In this step, I will show you how to insert the layer pieces into the frame, but keep in mind you will need to remove them to add the electronics later. First, you insert the top layer piece into the top slot, like so, with these ports indicating that it is the top of the device. Next, you insert the Raspberry Pi layer, which does line up with the holes for the Raspberry Pi ports as you see here. Next, you insert this layer, which contains the power distribution board, the multiplexer, and the battery. The slot for the power distribution board should align with this larger hole back here for charging. Lastly, insert the camera board, the camera layer into the bottom slot. I recommend allowing this larger space to be facing towards the back. Then, you slide this over top and can insert the last 4 screws like so. This is a complete assembly process of the frame. The next step in the construction of the A3Sat is the wiring. This is the most difficult step, and it can be one of the hardest to follow. What you do is you take the wiring diagram and find a wire that connects to the Raspberry Pi, right here. And then you trace that wire throughout the diagram. Say, for example, wire 3. Wire 3 goes up here, goes across here, goes down, and you'll see that it connects to the number 3 on the Enviro Plus. The problem is, with wiring, the Enviro Plus is designed to go on like this. So, on the Enviro Plus, this is 1, 2, 3, 4. It is backwards and opposite of the Raspberry Pi, which goes 1, 2, 3, 4. So, any number that you see here is just the reverse on this one. That's one of the things that makes this the hardest to follow. But, if I do the connection, where I go 1, 2, 3, right here, I can connect to number 3, which I know is on the opposite side here. So both 3's are connected between the Raspberry Pi and the Enviro Pi. Now I can continue this process for the rest of the wires. Now that the wiring of the Raspberry Pi, the Enviro Plus, and the multiplexer are done, we can move on to the soldering portion. This primarily consists of switches as well as the power distribution board. First, we need to use these 2 wires to connect power from the power distribution board to the Raspberry Pi. Right here, on the portion meant for the USB, there's positive and negative. We can solder directly into those in order to bring positive and negative power to the Raspberry Pi. When I put those wires through, I can then take my soldering iron, tin the iron, and begin soldering onto these pads. Then solder onto the next pad. With that, my positive and negative connections are done. This can then connect to the Raspberry Pi like so. Positive goes to 1, and negative goes to 6. 1, 2, 3, 4, 5, 6. Now, when we connect the battery, it will be able to supply charge to the Raspberry Pi. But first, we need to wire up the switch that will control the power. I take these wires, which is the male to male, and I need to solder them, like so, onto the switch. The switch requires 3 wires to determine its position. Now that the switch is soldered up, we can solder it to the power distribution board. If you look here, we need to solder it to the VS, EN, and ground, like so. It doesn't matter the order that you put them in as long as it is still outside, middle, outside. I can then take my solder and solder them together. Now the switch is connected, where in one position it will provide power and the other it will turn it off. The next switch that we have to solder is the recording switch. This will allow the Raspberry Pi to determine the state of the switch and determine if it should be recording or if it should be in standby mode. I'll take 2 wires from this and solder them to the outside and middle pins of this switch. Unlike the other switch, this only requires 2 wires instead of 3. Now, we can connect the switch to the Raspberry Pi. If you look at the wiring diagram, you'll see that the outside wire, this brown one, connects to pin 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20, and then the middle pin connects to 22, right next to it. This concludes the wiring portion of our project. Next, we need to hook up the cameras to the Raspberry Pi. The point of the multiplexer is to switch between the 2 cameras, so we need to use the ports for camera A and camera B to connect to the 2 cameras, visual and no IR respectively. First, we connect the visual camera indicated by the green PCB to the camera A slot, like so. Then we do the same for the no IR camera, indicated by the black PCB, into the camera B slot on the other side of the board. Now this board needs to connect to the camera port on the Raspberry Pi right here. You can remove the sticker and take the black cable that comes with your kit and connect it to this port right here. This then connects to the port on the Raspberry Pi, like so. And we're done. Well, yes, you'll have to rewire this in order to run it through the frame of the Raspberry Pi. These are how the wires connect to the cameras. Now let's take a look at how to install the operating system on the A3Sat. You should receive a link that will bring you to a shared Google Drive. Inside this drive will be everything you need to operate and use the A3Sat. It's probably how you found this video. What I suggest doing is right-clicking on the drive and selecting Download. This will download all the files directly to your computer. Just know that this process may take a little bit, as it needs to zip all the files and send them to you. Once your download's complete, you should see them in your Downloads folder. This project may have downloaded into two files, the zipped folder and the image. This is likely because the image is so large. First, we're going to unzip the folder. Right-click on the folder and click Extract All. Then Extract. Now that this is complete, you can delete the zipped folder if you want. What I then suggest doing is going into the folder and creating a new folder inside of it called Operating System. You don't need to do this step, it's just for organizational purposes. Then you can bring the image into that folder. And now everything's organized. Now we can take a look at how to install the operating system onto the A3Sat. To do so, you're going to want to grab your microSD card that came in the kit. Install that microSD card into your computer. After a few seconds, a window should pop up. Feel free to exit that out, as we're not going to have to interact with the files themselves. You're going to need to use a software called a disk imager. I personally recommend Win32 Disk Imager if you're using Windows, but Mac OS should have its own, as well as Linux. Using this software, which you'll have to download from the internet, you're going to want to select the image file from the operating system folder, and then select device, in this case device F. Then you select Write, and Yes. This process will take a few minutes, but once it's complete, it will be completely set up to be put into the Raspberry Pi of the A3Sat. Now that we've finished uploading the operating system to the SD card, we're ready to test our wiring and our download. First, take the SD card and insert it into the slot underneath the Raspberry Pi like this. Then, take the battery and insert it into the power distribution board like this. Before we power it on, we need to get our software ready to check. If you take a look at my computer, you'll see the Google Drive that we worked on before. There is a chance that the executable for the ground station on Windows didn't download. This is because executables are possibly seen as potential viruses by Google Drive, and they won't download in zip files. So you have to manually download like this. It will scan for viruses, but because it is an executable, it will almost always get flagged. You download infected file. Once again, it's not infected, it's just something that is seen as a potential threat because executables can contain viruses. Instead of hitting discard, you hit keep, and it will download to your folder. Then you take the executable, drag it into the folder for the ground station, for the documents and software, and put it into the ground station folder, the software folder, and the Windows version folder, and finally, once again, the ground station folder. Now, if I double click on this software, I click more info and run. This is just because it's an outside application. It'll run our ground station software, right, like this. Now, if we look back at the circuit, and I flip this switch, it will provide power to the Raspberry Pi and all other circuits. And I need to make sure that this switch is in the on position where the switch is overhead these two pins. That's just to allow us to connect via the software. Once the Raspberry Pi has booted up, I need to make sure that I connect to its Wi-Fi signal. Right here, the A3Sat Wi-Fi signal. Then I hit connect, connection established, and I select start. Now this will allow me to check all the sensors because I should get sensor data here, and soon I should get a picture coming through right here. This is health data coming in, and our infrared image should come in here. This shows us that every sensor and camera is working properly and that transmission is working. Now I can stop the transmission and use this switch right here to power down the device. Now that the wiring and software is done, we can begin to put the electronic parts onto the layer pieces that will go into the frame. Each component has its spot labeled out for you to screw it into. Note that the screws might not be required for all pieces. It might only require a few screws per piece, not for every hole that there is. It just depends on the size of the piece and the plastic. Use it at your own discretion. Now that I have all the electronics attached to the layer pieces, you can see that I have the power distribution board, the multiplexer, and the battery on one layer, with a strap holding the battery in, and 2 screws on both devices. Like I said, the number of screws you're going to use is going to heavily depend on the way your board lays onto the plastic. In this case, I was actually able to use all the screws, but did not need to use any of the nuts that came with the electronic screws. This is because it was a tight enough fit that holds it in just by itself. I've got the Raspberry Pi here with the I/O ports that will line up with the frame. I've got the Enviro Plus hooked up to the front piece so that will face outward, and then the 2 cameras on the bottom. Now, I can start inserting the layers into the frame. Note that the wires have to go between the layers, which you might need to undo the wires and reconnect them to go through these slots to go between layers. First, I'm going to insert the Raspberry Pi into this layer here. The second one from the top, making sure that the camera cord goes in the front or however it will best fit for you. Then I can insert this battery, multiplexer, and power distribution board layer into the third one down. Note that with the way the battery strap lies, it might not sit properly, but when you put the front on, it will seal everything up the way you need it to be. Then I'll insert the camera layer. Note that the switch for the battery layer needs to stay on that layer and can go through the switch hole on that layer. You might want to use pliers for this. Then I can take the switch from the top Raspberry Pi layer and insert it through the switch hole on that layer. If you think that this is a permanent setup for you, feel free to insert glue where the switch lines up with the outside so that it stays in, or you can let it just sit there based on friction if you want to take it out again. Lastly, I take this top piece and just slide it in, making sure to not catch any of the wires when I do so. Now that all the layers are in, I can put the front piece on. I need to tuck these wires through and find a nice place for them to sit inside that cavity. And then I can press this board into place, like so. Ooh, hey, there it is. And then I can start putting these screws in. First, one by one, to make sure it locks in. I recommend doing each corner so that way it stays in place. This will need to be undone if you want to get a visual connection between the CubeSat and a computer monitor, but this just shows how everything connects together. This is the part where having the nuts glued into place is very convenient, as without them, you have to try and hold the nut in place with your finger, which was a part of the original design, but was very inconvenient. Now, everything is put together into one structure. You might want to now take the chance to remove the stickers from the screen and from each of the camera lenses. Before, you might have noticed that the camera photos turned out a little bit blue. This completes the frame assembly. Now that you're done constructing and wiring the A3Sat project, we can boot it up onto a monitor and see what it looks like. I tend to use a power cord directly to the Raspberry Pi when powering it up for monitor use. You can run it off the battery, I just don't see the need in draining the battery. Just like this. You'll see it start to boot up on screen with this icon and the Raspberry symbols up here. I'm going to use a wireless keyboard and mouse combination to connect to it, but feel free to connect a wired one. This is what the desktop of your newly booted up Raspberry Pi will look like. With this pop-up, this is just because the default password for the device has not been changed from Raspberry. You can click OK. Feel free to change the password later. However, for convenience, you might want to keep it the same, as future students would be able to change it. The first thing I'm going to show you is that under the ground station software on the desktop, you click on Main, and you'll see a 1 at the top of the screen under Program Run. This 1 indicates that the program is going to start on launch. If I look at the other software on the desktop, Standard Recording, under Main, you'll see a 0. This 0 indicates that the program won't run. Feel free to change this 1 to a 0 and the 0 to a 1. Doing so will allow it to just do a standard recording where it does not connect to the ground station and just runs when you turn it on, versus this program where it will run only when you connect to a ground station and hit start. If both are written as 1 instead of 1 being a 1 and 1 being a 0, it will take priority with the ground station software. So be careful that you don't put both as 1, just try and choose which one you want to run at the time of boot. Now, in order to get the program to run at boot, I use a little command inside Terminal. If you open up Terminal, which will have this running as the software runs, you can ignore that. You can type in the code sudo nano /home /pi/dot-bash/rc. Running this command will give you this set of code, and at the bottom, you'll see these two lines which run the ground station with priority and then the standard recording. If you want to write your own code to run, just add it below this or change one of these for it to run on boot. The other option within Terminal is to change the wireless hotspot settings. When you are logged in as a hotspot for your computer to connect to, it's impossible for this device to connect to the internet. In order to get to reconnect to the internet, you're going to need to actually turn off the hotspot. To do so, you have to navigate to the folder which contains the files, which is CD desktop, CD being what you need to actually change folders, /auto hotspot with a capital A. Then I type in the command sudo /auto hotspot, no capital, --setup .sh. This will run the code, and selecting from these numbers right here will give you options such as to uninstall the auto hotspot or permanent hotspot, or if you want to set it up, you're going to choose 3, install a permanent hotspot. You can select 8 to exit and 7 to change the name of the Wi-Fi network and the password. I'm going to exit right now, but these are the steps you're going to use if you want to change any of these settings. This is everything you need to know to set up the A3Sat. Feel free to add your own code and experiment around with it. We switched to a larger display as you need to be able to see everything that's happening, as this step is mandatory for setting up the A3Sat. The SD card that comes on the A3Sat does not have the full space available to you. This step will allow you to access it so you can store more photos and videos for your recordings. First, navigate to the Raspberry symbol in the top left corner. Select System Tools and Gparted. Here you're going to need to enter your password, which by default should be Raspberry. Once this opens, you'll see a large chunk of unallocated space. Wait for it to load. Right-click on the allocated space here, click Resize/Move, and drag across the screen. Then select Resize. Then select the check mark to approve the resize and apply. Then you can close the box, and you'll see in your file settings that you have access to the full size of the SD card. Now we've officially completed the construction of the frame, the wiring of the electronics, the software installation, and the software elements. With that, you've officially completed the A3Sat project, and you're free to experiment around with it, collecting data, adding software, and overall learning about electronics, engineering, and data science.